Zoom session is being brought to you by the Fractal Fire. All right, for today, we go through section 2.3 about the properties of the trigonometric functions. We start with the circle definition of the trig functions. We start with a unit circle, radius 1, centered at the origin. Here's a ray at angle theta from the positive x-axis. This point here is at x by y. Cosine x equals the cosine of theta. Sine theta is defined as y. And we have these various ratios. Y over x is tangent, x over y is cotangent, 1 over x is secant, 1 over y is cosecant. These definitions are they ultimately derive from the right angle trig, so the oldest definition of the trig functions. All these have the problem that occasionally they zip off to infinity, where z's are always between -1 and 1. Cosine is between -1 and 1. Sine is between -1 and 1. Secant is the reciprocal of cosine, so it's either less than or equal to -1 or greater than or equal to 1. Similarly with cosecant. All right. So cosine and sine are defined for all theta. Tangent and secant are defined when the cosine, i.e. x, is not 0. That is, for all values of theta except odd multiples of pi over 2. Cotangent and cosecant are defined when sine is not 0, i.e. for theta, all theta other than even multiples of pi over 2. All right, now if you take an angle theta, here's x by y, and then you add pi radians to it, in other words, a half turn, then this point will be -x by -y. So therefore, cosine of the theta plus pi will be the opposite of cosine theta, and sine of theta plus pi will be the opposite of sine theta. Similarly, with the reciprocal, secant turns into its negative, cosecant turns into its negative after adding pi radians. I call this the half period law of pi for cosine, secant, and cosecant. They don't really talk about half periods in the book, but I think it's a good name for it. And because tangent and cotangent are reciprocal, are ratios of cosine and sine, the negatives cancel out, and therefore tangent of theta plus pi equals tan theta, and cotangent of theta plus pi equals cotangent theta. So tangent and cotangent have period pi. If you add any integer multiple of pi to the angle, you get back the same tangent and the same cotangent. That's not quite true with cosine and sine, but if you add 2 pi that is, then it negates twice and you get back to cosine theta. Cosine of theta plus 2 pi is cosine theta. In other words, if you go around one full turn, you wind up with the same cosine. Same with sine, adding one full turn gets you the same sine. Same with secant, same with cosecant, and same with adding any integer multiple of 2 pi. So trig function of theta plus 2 pi n will be the trig function of theta. So cosine, sine, secant, and cosecant have period 2 pi. Therefore, so do tangent and cotangent as well. So every trig function has period of 2 pi. Go add one full rotation, you get the same trig functions. Here, if we go up an angle theta to x by y, if you go down an angle negative theta, you'll wind up with x by -y. They're symmetric to the x-axis. So the same x value, so the same cosine, but the opposite y value, so the opposite sine. So cosine of negative theta is cos theta. This is what's called an even function. And the same for its reciprocal secant. Secant of negative theta is secant theta. Sine of negative theta is minus sine theta. So that makes it what's called an odd function. Excuse me for a moment. Ding. And so same for cosecant. Tangent and cotangent are a ratio of sine and cosine, and so when you take the opposite, one of those two flips, the sine flips, and therefore tangent turns into its opposite. So does cotangent. So sine, cosecant, tangent, and cotangent are odd functions. They transmit a negative. Cosine and secant are even functions. They absorb a negative. So we have various trig identities. These are equations that are true for any value of theta. Secant is reciprocal of cosine, cosecant is reciprocal of sine, tangent is sine over cosine, cotangent is cosine over sine, tan and cotangent are reciprocals of each other. Since these are sine and cosine are defined on the unit circle, where x squared plus y squared equals 1, therefore the same equation applies to sine and cosine. Sine squared theta plus cos squared theta is always equal to 1. This is called the Pythagorean identity. Identities plural I write here because there are a couple others. If you divide by cosecant, if you divide by sine squared, you get 1 plus cos squared equals cosecant squared. If you divide by cos squared, you get that tan squared plus 1 equals secant squared. I'll let that be. There's some questions about what the signs of the sine function of the trig functions are. For example, in the first quadrant, when you have an acute angle, all trig functions are positive because x and y are positive, and so are their ratios. Here in the second quadrant, where we have obtuse angles, y is still positive, but x is negative, so sine and cosecant are positive, but the others are negative. Here in the third quadrant, what I call breakback angle, the x and y are negative, so well, okay, cosine, sine, secant, cosecant are all negative, but the other two, tangent and cotangent, are positive. And finally, in this fourth quadrant, what I call a Pac-Man angle, x is positive, y is negative, therefore cosine and secant are positive, but all the rest are negative. So this is a little handy-dandy guide as to what the signs of the trig functions are. So we have some examples to work out. What is the sine of 405 degrees? Well, if you take away one full rotation, that is to say 360 degrees, you get sine of 45 degrees. And you can use the isosceles right triangle. Here's 45 degrees, 1, 1, and root 2. Sine is opposite over hypotenuse, 1 over root 2. Here's tangent of 19 pi over 6. What's that? Well, if you take 19 pi over 6 and subtract 3 pi, because tangent has period pi, it'll be the same tangent. And it turns out 19 pi over 6 over minus 3 pi is pi over 6, which is to say 30 degrees. So if you look at the 30, 60, 90 triangle with sides 1, 2, and root 3, tangent is opposite over adjacent, 1 over root 3, like that. If sine of theta is 12/13 and it's in quadrant 2, find all the trig functions. Okay, so we rotate theta radians. Its sine is opposite over adjacent. Here's 12, here's 13. This third side, we find it by the Pythagorean identity. It's negative, so we have a negative. Square root of 13 squared minus 12 squared, which after a bit of work comes out to be negative 5. So we have negative 5 here, 12 here, 13 here. Cosine is minus x over r, minus 5/13. Cosecant is 1 over sine, so therefore 13/12. Secant is 1 over cosine, therefore minus 13 over 5. Cotangent is x over y, negative 5 over 12. Tangent is y over x, therefore negative 12/5. What's tangent of negative 30 degrees? Tangent is an odd function, so the negative comes outside, minus tan 30 degrees. So here's a 30, 60, 90 triangle. Tangent is opposite over adjacent, minus 1 over root 3. Here they ask for sine 80 times cosecant 80. Well, it's not immediately obvious what sine and cosecant of 80 are, but we do know that they're reciprocals. Sine 80 times 1 over sine 80, so it cancels out to 1. Here we ask, if sine of theta is 0.3, then what's sine of theta plus 2 pi plus sine of theta plus 4 pi? Sine has a period of 2 pi, so this, and this are all the same. So it equals sine theta plus sine theta plus sine theta. 0.3 plus 0.3 plus 0.3 is 0.9. If tan theta equals 3, then tan theta plus pi plus tan theta plus 2 pi is what? Well, tangent has period pi, so this tangent and this are all the same. So you want it with tan plus tan plus tan equals 3 plus 3 plus 3 equals 9. Now here, they're being a little tricky. Sine of 1 degrees plus sine of 2 degrees all the way up to sine of 359 degrees. What's that? So you imagine a circle, 1, 2, 3, 4, 5, 6, 7, 8, 9, all to 239, all but sine of 260, which would be right here. Now, okay, sine is the height. And for each one up here, there's one down here. And so they all cancel out and sine of 180 is 0. So these all add up to 0. In the book, they'll ask, you're assigned a problem which asks for cosine 1 degrees plus cos 2 degrees all the way up to cos 359 degrees. So with the same diagram, only we're looking at the x values. And everything will cancel out except for this one, this cosine of 180, which is not balanced out by cosine 0. So you can get the answer with it that way. Okay. I think that's it for now.